Hey, Murray students, Miss Crowley here, Miss Ross and Miss Lee. So we're in our week 2 of fourth quarter. We're continuing to learn about heat transfer. So we're going to take some notes and then do a lab. If you hear growling in the back, it's just my dog. All right, so the goal today is I can describe the 3 types of heat transfer. So one is convection, we learned about that last week. The other one is conduction, and then there's radiation. So we are going to learn about conduction and radiation, and then also review convection. So we want to think about what happens to the particles in matter when the matter is heated up. So if you add heat energy, what's going to happen to the particles? Are they going to move faster or slower? Are they going to move closer together or farther apart? Are they going to become less dense or more dense? So think about that. And the answer is the particles are going to move faster, they are going to spread apart, and they are going to move up because they are less dense. Now, there might be a phase change because of this, so a liquid to a gas. And then also the thermal energy goes up. You're adding heat energy to it, so the thermal energy goes up. Now, here's our heat transfer notes. So they're guided notes. So you've already uploaded the worksheet to Notability, and then you're just going to fill in the notes. So anytime you see a word that is bold and underlined on your worksheet, there's a blank, and that's where you put that word. So heat is a form of energy, and it's also called thermal energy. So something that has more thermal energy has more heat energy. So fill in the blank energy and thermal. And then heat or thermal energy moves in 3 ways. So convection, that's what we talked about last week, radiation, and conduction. So convection, radiation, and convection. Heat transfer is the process of energy moving through or between objects. So just to always remember that heat always, always, always moves from something that's hot to something that's cold. So the heat transfer is always from something that is hot to something that is cold. So fill that in your worksheet, hot to cold. That's the direction heat moves. Now we've already talked about convection. And if you notice, one way to remember this, because there's 2 words, convection and conduction, convection has a V in it, and it's movement. So the particles are going to move when you transfer heat. It's a movement in liquids or gases. All right, remember this can't happen in solids because the particles in a solid are tightly packed together and cannot move over each other. They can vibrate, but they can't move over each other. So heat convection creates these convection currents. So if you look at the diagram, right, that travel through the liquid or gas and transfer heat to other areas. So where the flame source is, right, the heat source at the bottom heats up the particles. They move faster, farther apart, become less dense and go up. And then at the top, then they cool, they move closer together, and they are more dense, and so they sink. And so this is how we heat our homes. This is how we heat the atmosphere. And this is also what happens inside the earth with plate tectonics. All right, radiation. So this is the second way that heat's transferred. First was convection. Now we have radiation. Now radiation is transfer of heat through empty space. There's no direct contact. So the heat from our sun, for example, the sun's radiant energy, radiation, can travel all the way through space, 93 million miles. Takes about 8 minutes to get here, but it can travel through space and then get here and then heat up our Earth. So it can heat up the surface of the Earth. Right? We've all walked on black, like black top in the summer. It's really, really hot, right? Because the sun's energy is absorbed by the blacktop, and if you walk on it, it hurts your feet. You can also do this with a fire. So the heat that you feel from the sun, from a fire, from radiators are all example of radiation. Or heat, how about like from a microwave, right? How we heat our food. That's also another example of radiation. Now, conduction, here's a trick to help you remember. Conduction is direct contact. So convection was movement with a V, right? Because there's a V in movement and there's a V in convection. Conduction is direct contact. They must be touching. So it's the transfer of heat within or between materials that are touching and in direct contact. An example would be a metal spoon getting hot from the soup, right? Another one would be if you iron your clothes, right? The iron touches the clothing and the clothing gets hot and gets the wrinkles out. Or if you straighten your hair, right? The straightener, the heat is transferred to your hair and makes it straight, or if you're curling it. Those are going to be examples. Or if you take a pan and you put it directly on the stove, right? And the pan gets hot. And then the pan would touch the food, right? And the food gets hot. So there's got to be direct contact, conduction. All right. Now, one thing that you have to learn is the difference between a conductor or an insulator. So, heat insulator is a material that slows down the heat transfer, and less dense objects are better insulators. For example, your down jacket, right? It is an insulator, it keeps the heat in, right? Insulation that we use in our homes that keeps the heat in our home. Those are examples that are insulators. And then a heat conductor is a material that transfers heat very well or very fast. More dense objects are better conductors. So that's why metals are good conductors. So we use them for pans, right? But we don't want to use it on the handle, right? Because that would get too hot. So a lot of times then we put like a plastic there because that's more of an insulator. Okay, so conductors transfer heat very well or very fast, and typically more dense objects are better conductors. And insulators are not going to transfer that heat, so they keep the heat in. All right, now we're going to watch this video together.
Conduction, convection, and radiation. Objective: to understand how heat is transferred through conduction, convection, and radiation. Matter is made up of atoms. It is the motion of these atoms and molecules that creates heat or thermal energy. The more vigorously the atoms vibrate, the more heat the matter will have. Heat can flow from one place to another in one of three ways: conduction, convection, or radiation. Let's take a look at each of these processes. Conduction is the transfer of heat between substances that are in direct contact with one another. Metals are good conductors of heat. If we heat a metal rod at one end, the heat will quickly begin flowing towards the opposite end, confirming for us that heat flows through metals by conduction. Inside our metal rod, the atoms are closely packed. As they are heated, the atoms will begin vibrating. And as the heat increases, the vibrations will also increase, causing the atoms to collide with neighboring atoms. These collisions will continue, with the vibrations moving from the hotter end towards the cooler end and conducting heat through the rod. Convection is a transfer of heat due to an actual movement of the substance. This process occurs in liquids and gases, but not in solids. Let's observe convection in action. Fill a beaker with water and heat it over a burner. As the water heats up, we will be able to observe a swirling movement that's beginning. Water at the bottom of the beaker, where the flames are in contact with the glass, will get hotter and rise up, allowing the cooler upper layers of water to take its place. As we drop a few grains of sand into the water, we are able to see the swirling more clearly. The grains will begin circling with the heating water. This kind of circulation will continue until the water becomes uniformly heated. Convection is common in our atmosphere. As the sun heats the Earth's surface, warmer air rises up and cooler air from the surroundings will move in. Radiation is the transfer of heat without any medium or matter. The best example of radiation is sunlight. Heat from the sun will pass through space where there is no matter, eventually reaching the Earth. Microwaves are another common place we encounter radiation, specifically what's known as microwave radiation. Summary: conduction is the transfer of heat through matter due to the vibrations of atoms or molecules. Convection is the transfer of heat due to the actual movement of the matter. Radiation is the transfer of heat without any medium. Conduction.
Okay, there's the video. And now we are going to do a lab. Now you're at home, so we're going to do the lab in school, but then we are going to show you the results. So we're going to have a stations lab. You are going to fill it in. So we're going to have a review stations lab. Okay, heat transfer stations. So we're going to go over the stations that we saw. So we have conduction, remember, direct contact, convection, heat transfer in liquids and gases, and radiation, heat transfer through empty space. Okay, so here we had three different cans, one that was black, white, and shiny metal. So which one do you think would heat up the fastest? Okay, so think about that. And then what kind of heat transfer is that? So which one is going to heat up the hottest? And then what kind of heat transfer is that? Conduction, convection, or radiation? And then here we go. There's the answer. The black one is going to heat up fastest and become the hottest because the dark color absorbs most of the heat from the light. So it absorbs all the wavelengths of the light, the Roy G. Biv, and it warms up to the highest temperature. And that's going to be radiation, right? So the heat from the lamp came through the air and then heated up the water in the can. The next one is the candle spinner. So here you've got the candle and it's making it spin. So how is that moving? So how is that moving? And what kind of heat transfer is that? Conduction, convection, or radiation? Okay. And then here, the air around the flame is heated up. It becomes less dense, rises up, and then as the warm air rises, pushes through the blades at the top, and it pushes them to make them spin. And that is convection because it's making the air rise, right? And that's going to be convection. Now we have different metals. So we have aluminum steel rod, steel, copper, and wood. So they're going to be in hot water. So which one would feel the hottest and which one would feel the coolest? So out of aluminum, copper, steel, and wood. So the hottest one is that get heated by conduction, convection, or radiation. All right, so the hottest is the copper, so because it's the best conductor. It conducts the heat the fastest. The wood is the best insulator, and therefore it's going to be the coolest. And this is through conduction because they are all directly in contact with the hot water. And then we have the heater. So this is a space heater. How would the air heated by the heater move through the room? So if you look at the diagram, I think you can probably get that. And then what type of heat transfer is making this happen? Conduction, convection, or radiation? And it is convection, right? The air near the heater is warmed, becomes less dense, and rises up. As it gets farther away from the heat source, it cools off and gets more dense and sinks. And then the process starts all over again. And that's how we get these convection currents. Metal versus wood. So you could feel the metal pan and a piece of wood, and one of them is going to feel cooler and one is going to feel warmer. And what do you think it's going to be? Which one? The wood, is that going to be cooler or warmer? And the pan, now the pan is not on a heat source, it's just they're both air temperature. Okay. And what type of heat transfer is making this happen? So remember, you're placing your hand on each one. So they are in direct contact. Direct contact with a D, right? So it is going to be conduction. And the one that feels cooler is actually the metal pan. A lot of people guess that because they think it's going to be hot because we cook with a pan, but it's going to be cooler. And then the warmer feeling one is going to be the wooden block. And that's because the metal is more dense and it's a better conductor of heat than wood. So it takes the heat energy away from your hand, because remember, your hand is hot. Your body temperature is 98.6 degrees, whereas the metal pan and the wood are at room temperature, about 70 degrees. So the heat from your hand is going to move, because remember, it always goes from something that's hot to cold. The heat from your hand is going to be transferred to the metal pan, and it's going to make your hand feel cooler. Okay. And then with the wooden block, it's an insulator, right? So it's going to feel warmer. All right, look at these infrared images. Examine the images that shows the heat transfer in penguins and in a house. What observations can you make about how heat transfers, and what type of heat energy is shown here? So is this conduction, convection, or radiation? So look at that. You can see where the house is losing the heat is coming out of the house or out of the penguin. Okay, and is that conduction, convection, or radiation? It is radiation. You are right. So the heat is escaping around the windows and doors of the house and around the eyes of the penguin. Insulation in the walls and the roof of the house are slowing the heat transfer, and the feathers in the penguins are slowing the heat from escaping their body. So if you look at the infrared images, right, to see the temperature of what's warmer or colder, right? So with the purple is the coldest, and then the hottest is the red. And so you can see the different temperatures. And this is going to be radiation. All right, a mylar blanket. If you feel the heat of the lamp, okay, so you're going to put your hand near the lamp, and then you're going to take the mylar and wrap your hand in it, and then feel it again. Same distance and everything from the light. Would it feel different? And it does. What is causing it to feel different? And how does it feel different? So is it warmer or cooler? What type of heat transfer is coming from the heat lamp? So what type of heat transfer is coming from the lamp, the light source? It is radiation. Remember, light can travel through empty space. Your hand actually feels cooler behind the mylar because the radiant heat from the lamp is reflected off the shiny surface. So your hand feels cooler behind the mylar because the light is just bounces off of the mylar blanket because it is reflected. Okay, and the heat transfer again is radiation. All right, last one, glitter lamp. Be amazed as you watch the glitter rise and fall. What is causing the glitter to rise and fall? And what type of heat transfer is making this happen? Conduction, convection, or radiation? It is convection, because you can see it's in a liquid, and the heat source, see how the stars, right? They get heated up. The liquid gets heated up near the light source. It moves faster, farther apart, becomes less dense, and rises, and it takes the stars with it. So this is convection. And then at the top, the molecules cool down, they move closer together, become more dense, and they sink. So that's convection. All right, now you are done. Upload your completed worksheet and take the closure quiz in Schoology. All right, we'll talk to you next week. Or no, Wednesday, Thursday. Bye, guys.